All right. Hi, everyone. Welcome to this session. First of all, good morning, good afternoon, and good evening to all of you from wherever you're joining us for this session. Today, we have a high octane series session with you. It's based out of probability. We'll be solving a lot of questions in this session. But before we move into that, I just want to confirm if I'm clearly audible to all of you or not. So very quickly, just type me a yes in the comment section if you can hear me clearly. There's a slight lag between when I speak and when you guys hear. So we'll take around 10 seconds to check this out. And once that is done, let me start the session. So let's take 10 seconds. If you can hear me clearly, please mark a yes. All right, that is perfect. So I have already gotten responses from some of you that you can hear me clearly. So let's get started for this session. Now, as I told you, we'll be solving some really cool questions on probability. Now, let me introduce myself. I am Atraya Roy. I'm one of the GMAT strategy experts and also a quant expert here at eGMAT. With me, I'll be your primary host for today's session. With me, I have Harsha. Harsha is also a GMAT strategy expert here at eGMAT, and he'll be our secondary host for today's session. The agenda for this session is very clear. We'll try to solve out a lot of questions so that your comfort level with probability increases, and we'll try to do that in less than 90 minutes, right? So let's get started. And before we start, the session is based out of the Quant 2.0 product that we have recently launched. And if you have not gotten a feel of that, I request all of you to get a feel of that. We have some tremendous success, and that has been throughout the months that we launched the product over here. And you can see over the results, we had the most number of Q49 scorers and the most number of reviews over this period of time. And also that goes on and on with month on month. So the purpose for this session, now in this session, I'll help you understand that you have to have a strong understanding of basics, and you have to have a particular structured approach to solve questions. Now, when you have both these things, acing GMAT quant is not at all a difficult task, right? So what's the flow of the session? So I've brought a warm-up section first, and this warm-up section will have 6 probability questions. The level of these questions are fairly easy, they are around that 500 to 600 level, and then we'll do a concept revision through these warm-up questions. Once that is done, we'll move on to sprint 1. Now, sprint 1 is fairly difficult questions. I'll have 3 questions here. The level of these questions are around that 600 level to 700 level over here. Once that is done, we'll move into sprint 2, where we'll be solving 2 very good questions, and both of these questions are 700 plus level questions. I'll give you feedback and takeaways after each sprint and throughout the entire session with all questions that we would do, and we'll also talk about faltering points that's most common with students solving these kind of questions on probability. With that, let's now move into the warm-up section. In the warm-up section, we have basic questions that I've already told you all. The solutions are not that detailed, but again, they are much detailed. You won't have any confusion understanding them. I'll also give an understanding of your conceptual knowledge after we're done with the warm-up section over here. So, 2 very important things. I'll not I don't want you people to put in your answers in the YouTube chat that you can see over here, right? So please do not do that. Kindly refrain from doing that. We'll be sharing polls for all questions over here. That also gives me an idea to check the accuracy level and all the data around that, right? So use the polls to mark your answers. And one thing before I move into the questions, always remember, probability is calculated using the very simple formula, the total number of favorable outcomes divided by the total number of possible outcomes over here. With this, let's start and let's move on to the first and the second warm-up question. You would get the link over there. Harsha has already put in the link over there. All the best for these 2 questions, guys. All right, last 10 seconds, guys. If you have not put your answers in the poll, please do that. I'll only give you another 10 seconds. I already see a lot of responses in the poll, and the responses have been good. So let's take another 5 more seconds. 3, 2, 1, and 0. All right, let's now come back over here and look at these two questions. Now, I've given you two very simple questions. Very honestly, these are not that difficult. The first question has an accuracy of 64%. The second question has a higher accuracy. So let's get started with the first question. Now, what the question is asking me is, in a toss of 3 coins, that's the information that's given. I am asked, what is the probability of getting at least one head, right? So there are two sides of a coin, a tail and a head over here. So my event over here that I need to find out, the probability of the event that I need to find out is getting at least one head. Now, if this is my event, what's my non-event? So I'm just thinking out loud. What are the cases that I cannot consider? I cannot consider the case where all of the coins show a tail on them, right? So that's not possible. That is something that I cannot consider. So remember that formula that we have, the concept that we have in probability. The probability of an event is equal to 1 minus the probability of non-event. That is, the probability of something happening is 1 minus probability of not happening, right? Not something not happening. Again, what is the non-event over here? When all are tails. I cannot take those cases. When all of the coins show tails, I cannot take those cases, right? Now, how many total ways would I get? The total number of ways in which I'll get outcomes. The first place can be a head or a tail, so 2 ways. The second place can be a head or a tail. The third can be a head or a tail. So the total number of ways would be equal to 2 to the power 3, which is equal to 8. And there's only one way in which all the coins would show a tail. That is when I have tail in the first and the second and the third coin, right? So there's only one such way. So what's the probability of non-event? That means what's the probability of not getting or getting all tails? That's equal to 1 by 8. So if that's the probability, that's something that I cannot consider. The probability for my event would be 1 minus the probability of the non-event. That's equal to 1 by 8. So 1 minus 1 by 8, 7 by 8 is the right answer for this question. I hope the solution is clear to all of you. One very, very important concept over here is this. Now, why would we use this? The calculations are made simpler, the number of cases are made simpler, and that's the reason we use the formula of P event is equal to 1 minus the probability of a non-event. All right. With that, let's move on to the second question. As I told you, the second question had a higher accuracy. I had 72% of you mark this question correctly. Now, what did I have in this question? The number is randomly selected from the first 48 natural numbers. So what is the probability that the number is divisible by both 3 and 5? Okay, the keyword over here is both 3 and 5. Anyone who missed this keyword would make a mistake in the question. Now, I need to find out numbers which are both divisible by 3 and 5. What's the LCM of 3 and 5? It's 15. So if a number is divisible by 3 and 5, it has to be divisible by 15, right? So in the number list that I have, the first 48 natural numbers, it's 1 to 48. Which are those numbers which are divisible by 15? I have 15, I have 30, and I have 45. So I have 3 total numbers which are divisible by 15, right? So how many favorable outcomes do I have? 3 favorable outcomes. How many total outcomes do I have? Any of those 48 natural numbers, right? So total 48 outcomes is the total number of outcomes that I can have. So what's the probability? As I showed you in the second last slide, it's the total number of favorable outcomes divided by the total number of possible outcomes, which is 3 by 48. 1 by 16 is absolutely correct for this question. Now, I hope the solution for these two questions are clear to all of you. If yes, then let's move ahead to the next two questions. Slightly more involving, but again, keep that in mind. It's not that difficult. All the best for these two questions. All right, the last 5 seconds, guys. Last 5 seconds. If you have not marked the answer, please mark it. 3, 2, and 1. All right. Let me give you two very interesting, insights from this question, from the polls that I was seeing, the answers that you people were marking. One, the sum of the percentage accuracies in both the questions never crossed 100. So it touched 100. I had a 62 and 38. I also had a 53 versus 47, if I remember correctly, but it never surpassed 100. So again, I want you people to understand these questions very nicely. Only then the next set of questions that I have for you would get a bit easy for you. That's one. The second thing is, how many of you attended my last session that I had on permutation and combination? It was held on last Tuesday. We had around, we again solved around 12, 13 questions, again, around in 70 odd minutes. So if you have not watched that video, please make sure you watch that video, because in that case, solving questions would become a bit easy. If you are strong at PNC, probability tends to become a bit easy. Okay, so with that, let's move on to these two questions now. The first question, a number is randomly. Okay, and before that, let me also give you the accuracy numbers. So for the first question, I had 46% of you telling me correctly, marking the answer correctly. So the accuracy for the first question is 46. Okay, a number is randomly selected from the first 48 natural numbers. What is the probability that this number is divisible by any of 3 or 5? So this is the keyword over here. Any of 3 or 5, right? So this is something that you have to read properly. If you do not read it, you might think that it's 3 and 5, make a wrong answer choice, mark a wrong answer choice over here. All right, so let's get started. We have to look for numbers which are divisible by 3 and divisible by 5, right? So what are the numbers which are divisible by 3? They're of the form 3k. So the numbers are 3, 6, 9, all of those, and the ones which are divisible by 5 are of the form 5m, let's say, and they are 5, 10, and all of those numbers, right? So how many divisible by 3, how many numbers do we have which are divisible by 3 within 1 and 48? They start from 3 and with 48, so I have a total of 16 such numbers. What's the same thing for numbers which are divisible by 5? It's the list is 5, 10, 15, it goes till 45, so I have 9 such numbers. Now, one big mistake that students essentially make over here is they add 16 and 9, so they have 25 numbers. That's the total possible cases. However, there are always these cases which get counted twice, right? So numbers which are divisible by both 3 and 15 would be in this list as well. Let me mark that out, in this list as well, and would be in this list as well. So for example, 15, 30, and 45, you can already see 15 and 45 over here. The same 3 numbers would be over here as well. So I'm double counting cases, right? I only have to count them once, not twice. So please make sure you do this. Okay, if I cancel off those double counted numbers, so essentially the numbers which are divisible by 3 or 5 are the numbers which are divisible by 3, divisible by 5, and then I'll subtract the double cases. So I'll have 16 plus 9, that's 25, minus the 3 double cases, that's 22. So the total possible cases are 48. The total favorable cases is 22. The answer for this question is 22 by 48. That's 11 by 24, which only 46% of you marked it correctly. I hope the solution is now clear to all of you, and the learning is also clear to all of you. Again, read the question properly. Make sure you don't count something twice. With that, let's now move on to question number 4. This is something that I covered already in the PNC session that I've taken last week, right? Let's read the question again. What's the accuracy for this number? It's a startling number for me. I'll just go and check it out. But if I remember correctly, it was 26%. Yes, it's actually 1% lesser to that. So it's now at 25%. So the accuracy for this question, again, this is not at all that difficult question. If you had attended my session, you would have gotten this question correct. Now, if all the letters of the word basics are arranged, what is the probability that there is at least one letter between the two S's in my arrangement? So I first have to understand what are the favorable cases. I also have to understand what are the total number of possible cases, right? The possible arrangements of these letters, of these letters that I have in the word basics. So let's first understand what kind of words are possible. It's essentially anything. If I have one letter between the two S's, if I have two letters between the two S's, or let's say three letters between the two S's, all of these are possible cases, right? What are the cases which are not possible? The cases where both the S's are together. So here I'll not have any letter between the two S's that I have. So if I calculate all cases and then subtract the cases where the two S's are together, I'll get the number of words that I can form where I have at least one letter between the two S's over here, right? Okay, so now let's move ahead with this. So what do I mean by all cases? All cases means all possible arrangement of the six letters that I have. What do I mean by two S's together? That means when both of the S's are considered as one single element, and then I arrange all the letters over here. So let's very quickly understand that. In how many ways can I arrange the letters of the word basics? There are total of six letters in which two are common. Both of them are S's, right? So I need to have 6 factorial, need to divide it by 2 factorial because two letters are common over here. So I have a total number of 360 ways to arrange the letters in any which way. However, in how many ways will both of the two S's be together? You consider SS, the two S's, to be one single element. So I have one element over here, 1, 2, 3, 4. So I have a total of 5 such elements. In how many ways can I arrange 5 elements? In 5 factorial ways. Can the letters over here be arranged as well? Yes, they can be arranged in 2 factorial ways, but also understand that both of them are same, right? Both of them are the same letter. So I also have to divide it by 2 factorial ways over here. So what's the total number of ways in which I'll get both the S's together? It's 120. So 360 is total, 120 is in which I'll have both the S's together, right? Now, so essentially, what's my favorable cases? As we discussed in the last slide, total minus when both the S's are together would be the total number of cases where I'll have at least one letter between the two S's over here. So that gives me 240 letters over here. Now, what's the probability? The probability is equal to the favorable cases divided by the total cases. And what's the total number of cases? 360. Any which arrangement, right? So 240 by 360, the answer for this question is choice D. Again, I hope the learning is clear to all of you. In case there's anything, any issue with this question, I definitely recommend you to go and watch back the PNC session. You just need to go to GMAT Club YouTube channel, go to videos. My session would be in the first 5-6 odd videos over there, right? So you get to see that. But yes, please go and watch that out, right? So the answer for this question is choice D. With that, let's move ahead and let's solve question number 5 and 6. These are a bit more involving. I hope you would be able to solve them with higher accuracy. All the best for these two questions, guys. The link again is in the chat pod. I don't want you people to use the chat pod to mark your answers. Please answer the poll. All right, last 20 seconds to mark the answer for these two questions. Let's take 20 more seconds to mark the answer. And again, Vikas, I'll request you not to put in the answer in the chat pod, please. That is the reason we share the poll links over there. Please use the poll and mark the answer. Thank you. All right, now let's discuss these two questions. Let's first discuss the accuracy for the first question. Question number 5, I'm very, very happy. You know the reason. You had 100% accuracy over here. So much better than the last 2 blocks of questions that we solved over here, right? So very well done over this question. I have 2 very interesting questions in the chat pod. Now, Vinayak asks me how not to make careless mistakes. I had to subtract from 1. So he calculated 1 by 3, you could not subtract from 1 by 3. Again, you have to ensure that you read questions properly. You write everything down. The moment you start writing things down, you'll see that the chances of getting, making these silly errors or the careless errors that you call, they would go substantially, they'll reduce substantially. So please make sure whatever you're doing, write that down. And write that down while you're reading the question. It won't take a lot of time. So please do that. Yes. Okay. Then I had another question from Lakshit. What would we do in the last question? Obviously, what would we do if there are at most 1 letter? Okay. So that's a very good question. So there would be 2 cases. I only have 1 letter. So I have to make cases in that. I have no letters. That's what we have already calculated. Then I have 1 letter. And then you need to arrange and check with the position of S and S. So you have to fix S and S and then make all the arrangements over there. I hope, Lakshit, that answers your question. With that, let's now move ahead and solve this question. Question number 5, we had 100% accuracy, so I'll rush through a bit quickly. Okay, so what's the question asking? Giving me, it's telling me that A is to be chosen from a random set of the first 7 natural numbers, K is to be chosen from a random set of 9, 10, 11, 12, these 4 numbers. What is the probability that the product of A times K would be odd, right? Now, when is a product odd? A product is always odd. Product of 2 numbers is always odd when both of the numbers are odd, right? So let's look over here. So the product is odd when both A and K is odd in nature. So A has to be an odd number. That means A has to be 1 or 3 or 5 or 7. So 4 possible favorable values. K has to be either 9 or 11. So 2 favorable values for K. Now, what are the possible values of A and K? K can be anything between 1 and 7. So 7 cases for that. K can be anything between 9 and 12. So 4 cases for that, right? Now, I have the total number of favorable values. I have the total number of possible values. What is the probability of choosing A to be an odd number? Of choosing an odd A would be equal to favorable cases, that's 4, divided by total cases, that's 7. Similarly for K, it would be favorable cases, that is 2, divided by total cases, that is equal to 4. Now, I need to calculate the products the probability of the product being odd, right? So A needs to be odd and K needs to be odd. And what do I mean by and? The simple meaning in probability and PNC of and is multiplication. So what I have to do over here is 4 by 7, that's the probability of choosing an odd A, times 2 by 4, that's the probability of choosing an odd K, and multiply that. 2 by 7 is the right answer for this question. Hope the solution is clear to all of you. Now let's move into a very interesting question that I have over here. Again, something that's very common as well. If you have been taking mocks, if you have been solving questions out of probability, this is something that you've fairly noticed or fairly solved before. What do I have? I have 3 students, Alex, Bob, and Caleb, independently try solving a difficult probability question. Okay, the probabilities that they can solve the question individually are 2 by 9, 4 by 7, and 2 by 5 respectively. What is the probability that the question is solved? So I need to find out the probability that the question is solved. Now, just think it out. How would the question be solved? If any of these 3 people solve the question, then only I can say that, wow, the question is solved. But the question would stay unsolved if all of the 3 friends that I have over here, Alex, Bob, and Caleb, are unable to solve the question, right? So the first statement is essentially my event. I need to find out the probability of any one of these three friends at a minimum to solve, at least one of these friends to solve it. If they can, then my answer, then I can get to the answer. However, what's the non-event for this? The non-event for at least one is all minus, or one minus, that is the one is the universal probability, minus that none of the three friends can solve it. Right now, none of the three friends can solve it is essentially the non-event over here. If I subtract the none of the students can solve it from one, then I'll get the cases where at least one student can solve the question. Again, keep in mind that the concept used over here is probability of an event is equal to 1 minus probability of a non-event. All right. Now, once that is done, let's now understand what does the none part mean over here, the non-event part mean over here. The non-event part means that neither Alex nor Bob nor Caleb can solve this question, right? So what's the probability of Alex not solving? It's equal to 1 minus the probability of Alex solving. So that's 1 minus 2 by 9. That's equal to 7 by 9. Remember, 7 by 9 is the probability of Alex not solving the question. Similarly, for Bob, it's equal to 1 minus 4 by 7. That's 3 by 7. And for Caleb, it's 1 minus 2 by 5, which is equal to 3 by 5. All these numbers over here that you can see over here are essentially the probabilities of not solving the question. So I had already written over here, right? Not Alex and not Bob and not Caleb. That's my non-event. So what's the probability of my event? That's 1 minus the probability of non-event. This is the probability that Alex can solve the question. This is that Bob cannot solve the question. This is for Caleb not being able to solve the question. Calculate this out, you would get 1 minus 1 by 5. That makes 4 by 5 the correct answer choice for this question. Right? So I hope the solution for this is clear to all of you. Now, Prashant has a very interesting point. Easy to solve by elimination. The answer must be higher than all of the probabilities. Very good observation over there, Prashant. But again, even if you had that observation, I'm very happy for that. But please also make sure that you understand the solution in and out. Okay, I hope the solution is clear to all of you. And if you have any questions, any doubts, you can always put that in the comment section. I'll be very happy to take that over here. So, warm-up questions done. We had solved 6 questions in almost around 30 minutes. I hope this gave you a very fair idea of what concepts are tested on the GMAT probability. Also understand that these are not that difficult questions. If you are scoring well, if you're getting questions correct in GMAT Quant, you would be thrown difficult questions, more difficult than these ones. And these questions that you would be thrown, just give me a moment over here, please. Yes, these questions that you would be thrown in your GMAT exam are essentially questions which would require a much advanced level of applications of the concepts that we have learned in the last 6 questions, right? Okay, and again, if you need to learn more about that and you need to if you want to become better, I should rather say, if you want to become better at other topics, do make sure that you register for the upcoming sessions. We have a session that Rajat is taking that's on GMAT strategy, and here we'll be discussing about PSP, about metrics, about everything that you need to ensure at your end to make sure that you hit your target GMAT score in the first attempt itself. That's on 17th of July. Let me very quickly go to the slide. That's on 17th of July. That's on Saturday, 7 a.m. PST. The registration link for the same is given in the chat pod over here, as you can see. The next day, that is on Sunday, I have, and I'll be conducting this webinar, I have a session on number properties. The GMAT number properties webinar is one of the most attended webinars that we have over here. It's on Sunday, 7 a.m. PST. We'll be discussing about unified approaches. We'll discuss about very cool tricks and tips and smart ways to solve questions. And I'll also help you to understand how do you solve questions out of divisibility and remainders with 100% accuracy under 2 minutes. And we'll test that out using certain number of questions that we have over here, right? With that, let's now move into the first sprint. Now, again, understand these questions are slightly more involved, not that difficult. I'm not trying to scare you out, but they are slightly more involved. I'll give you the first question. Again, please use the poll to answer the first question. All the best for this one. All right, let's discuss the solution for this question, and not that difficult a question, right? The accuracy for this question, if we very quickly check out, is 81 percentage, which is good, and is again understand it's higher than the warm-up question, so that's good. Okay, so what is the question telling me? It's telling me there are 9 red and 4 blue balls in a basket. Okay. um, Basket A, all right, and there are a total of 16 balls in basket B. One ball is randomly picked from each basket. Okay, so I pick one ball from basket A, one ball from basket B. The probability of both the balls being blue is equal to 1 by 4. How many blue balls are there in the second basket? That's what I have in the question. So let's get started. The first thing that I want you to do for this question is just visualize. I want you people to visualize, because if you do not visualize the questions that I have towards the end, you would not be able to get them, right? So please do this activity for the next set of questions that I have for you. Okay, so I have two baskets, basket A and B. In basket A, I have 5 red, 4 blue. That is a total of 9 balls. In basket B, let me assume that there are a total of X blue balls. Now I know that there are a total of 16 balls. So if I consider that the number of blue balls is equal to X, the number of red balls would be total balls minus the number of blue balls, which would be equal to 16 minus X. Now, what's the question giving me? The question is giving me the probability of both the balls being blue. That is, the ball that is taken out from basket A is also blue, and the ball that's taken out from basket B is also blue. So that probability is given to me. Okay, so that is equal to 1 by 4 according to the question. Now, what is the probability of choosing one blue ball from basket A? I have a total of 4 blue balls, and the total number of balls that I can choose from is equal to 9. So probability of choosing a blue ball would be 4 by 9. For basket B, I have X balls and a total of 16. So the probability of choosing a blue ball would be X divided by 16. Now that's given as 1 by 4. Simply cross over. You can cross 4 and 16. I have a 4 over here, and you can multiply both the sides with 9. If you multiply by 9, I cancel off this 9, take a 9 to the right hand side. I can cancel off these 4s as well, and then what do I have? I have the value of X. The value of X according to the question is equal to 9. So the answer for this question is choice E, which 81% you got correct, and I'm very, very happy. So good job, all of you. With that, with this learning, let's now move on to the next question. Question number 2 from sprint 1. All the best for this one, guys. All right, I'll give you another 20 seconds for this question because I see the answers are coming a bit slow. So take your time, please. Take your time, answer this question. I'll may just make sure that you answer it correctly. That's it. All right, let's discuss the answer for this question. Now, again, if you have attended my last session, then this was a question that I saw over there. I made sure that you understand how to make sure that how to make sure that you get questions where I have arrangements based out of constraints, because that is something that students really struggle. And I'll give you an accuracy number for this question, which would say you that even this question had something very similar on that front as well. Now, the accuracy for this question is 55%, right? It's at a 55%, which is fairly fine. I would not comment on that. It's fairly fine for this question. So let's look at over here, over this question here. Now, a 3-letter code for a laptop key uses the letters A, B, C, D, E, F, G, H. So I have a total of 8 such letters. Keep that in mind. What is the probability that the first letter is not A or B? The second letter is either A or B, and the second letter and the third letter are both not A. So let's find out how many favorable cases would I have. Because calculating total cases has always been very easy in probability, So that's always something that you should focus on. You should calculate the favorable number of cases always. Okay, so now first try and think to visualize the question. Just think out loud and visualize the question. I have 3 such blocks, as in the 3 places where I need to put in a letter, right? The first letter cannot be A or a B. The second must be A or B. If the second is A, the third cannot be A, right? Okay, so since the second has a very crucial condition that it has to be either A or B, let's make 2 cases. Let's make sure that the first case is the case where the middle letter is A, and the second case is the case where the middle letter is B. Now, if the middle letter is A, let's look at the constraints over here. If the middle letter is A, the first letter cannot be A or B, right? It cannot be A or B. So in how many ways can I fill it? Everything apart from A and B, that is 6 letters, right? In 6 ways. The middle letter is A, so only one way to fill this. If the middle letter is A, the last cannot be A. So for the last letter, I have everything apart from A, that is 7 possible cases. Now, how many total cases can I have from this major case over here? I can have a total of 42 sub cases, right? So that's my case 1. Let's now move to case 2. Case 2 is what? Case 2 is basically around questions, around the case where the middle letter is B. If the middle letter is B, okay, let's first again understand what can be the first letter. Everything apart from A or B, that is all the 6 letters that I have over here. The middle letter is B, that means it can be only filled in one way. The last letter cannot be A if the middle letter is A. Okay, is the middle letter A? No, right? So the last letter can be anything. I don't have any constraint with that because the second letter is not A over here. In that case, in how many ways can I fill that out? 8 ways. So total number of subcases over here, 48. Total number of subcases in the first case, 42. So the total number of favorable outcomes would be 42 plus 48, that's equal to 90. Now these are the favorable outcomes. Now let's move on to the possible outcomes, the total possible outcomes. The total possible outcomes would be all the outcomes which essentially does not have any restriction, right? So for the first case, I can have any of the 8 letters. Same for the second and the third case. So the total possible outcomes would be 8 times 8 times 8, which would be equal to 512, since I have no restrictions over here. So what's the probability? The probability is the total number of favorable cases, that's equal to 90, divided by total number of possible outcomes, that's 512. Simplify that, your answer is 45 by 256, which is choice B for this question. So what did we learn in this question? Visualization is very, very important. Making cases with constraints which are definite in nature are easier than with constraints which are not definite in nature. So that's there. And finally, always calculate favorable outcomes first, because total possible outcomes is very easy to calculate. That won't take you a lot of time at your end. With these learnings, let's now move on to the third question. And the third question is a personal favorite of mine. All the best for this one, guys. All right, last 10 seconds for this one. If you have not marked the answer, please mark your answer in the poll. Let's very quickly get to the answer. All right, with that, let's now move into the question, and just give me a moment over here. I'll get the accuracy numbers. All right, so yes. Now, the accuracy for this question stands at a 42%, which is good, basis this question, because this is a difficult question. It makes you think a lot even before. It's a single line question, to be very honest, but the thinking that you need to do before moving into the solution is really a lot. And that's the reason with 42, I'm fairly happy. I'll make sure that after today, you do not make an error in these kind of questions at any point in time. Okay, so let's get started. So a couple decides to have 5 children. Each child is equally likely to be a boy or a girl. This is a very, very important constraint over here, I would rather say. It's a very important piece of information. It's also a constraint because this would, essentially ask me to use a certain method to solve this question. I need to find out what is the probability that the couple has exactly 3 girls and 2 boys. Now, the first question that I would ask is, in how many ways can the couple have children? Some might say I can have it in 6 ways. By that I mean 0 girls, 1 girl, 2 girl, 3 girl, 4 girl, 5 girls. So 6 possible cases. However, since it's mentioned over here that each child is equally likely to be a boy or a girl, think like this. The first child, he can be a guy or she can be a girl, right? So basically there are two ways for each children to be born. And since there are two ways, right? Since there are two ways and I have 5 total children, that means 2 ways for the first children, 2 ways for the second, for all 5, 2 times 2 times 2 times 2 times 2, that's 2 to the power 5. That means I'll have a total of 32 ways in which I can have the children, right? Now, understand that the order is mattering over here, because the first child can be a girl, the second can be a boy. That is different from the first being a girl, the second being a girl, the third being a boy, right? So please make sure that happens. Okay, if total number of ways have an arrangement scenario over here, the favorable cases would also have an arrangement scenario. We need to find out the cases where 3 of them are girls and 2 are boys. They can be in any order, right? Okay, let me assume that a girl is represented by G and a boy is represented by B. So 2 boys means 2 Bs and 3 girls means 3 Gs. So I just need to make sure that they can be arranged in any order. The first can be a girl, the second can be a girl, in any order. I just need to make sure that these 5 letters are arranged. In how many ways can I arrange 5 letters? 5 factorial. However, in how many ways can I arrange 5 letters in which 2 are same, 3 other are same? I need to divide it by 2 factorial and 3 factorial. Calculate this out, the total number of ways becomes 10, right? So total number of ways 10, that is having 3 girls and 2 boys. However, these are the favorable cases. The total possible cases of 5 children, 32. So the probability of this event is 10 by 32. That translates to 5 by 16. That is essentially choice T. So one very important thing that we learned in this question is the order does matter, number 1. The second is, if order matters in the denominator, it should also matter in the numerator. That means I'm talking about total cases and favorable cases, right? That's how I'm translating this. After this day, now that you've learned this question, anytime if you see this question, please make sure you make these cases. That is 2 to the power the number of children. That's the total favorable cases. And you then arrange the boys or the girls that you have over here. Okay, so Shashank has a question. Why did we consider 5 factorial by 3 factorial times 2 factorial? Understand, I'm trying to differentiate boys and girls. I'm not trying to differentiate each girl as well, right? And that is the reason we treat all the girls to be same, all the boys to be same. I hope that clears that clears your doubt. Again, I'm looking for 3 girls and 2 boys. The girls, I'm more not so let me give you this. I'm not into the fact that the first girl was the oldest, or the second girl had blue eyes, or the third girl has yellow hair or something like that. Not at all that. I'm just trying to figure out that I have 3 girls and 2 boys. I need to arrange the girls. The characteristics does not matter to me in this question. Very good question, however, because this is something from which a lot of doubts also stem. So it's a very good question. I hope my solution and my response clears your doubt over here, Sashank. Right? Okay, with that, let's now move ahead with the next question. Just give me a moment over here. Let's now move ahead with the next question. And in the next question, before I even move ahead to the next question, I'll be helping you understand that these are the most difficult questions of the session. I have 2 such questions. Both the questions are of 700 plus level of difficulty, right? Okay, so before moving ahead, again, I want you to take a look at our Quant 2.0 trial. Now, why would you take a look? This might be a very big question, right? Because the Quant 2.0 trial has an adaptive learning architecture. So you only learn what you need to learn. It's completely, it's completely a very good experience for all of you. You just log into your eGMAT trial, and I've given the permutation and combination module example over here. What you do is you take the diagnostic quizzes. You get to know what is your starting score. Then, based on the diagnostic quizzes, the platform would tell you what all things do you need to learn, what all do you not need to learn. So you only invest your time in things that you are not that much good at, right? So you go through all of that content over here, whatever you need to learn, and then you take the practice quizzes to check how much have you improved from the diagnostic quizzes to the practice quizzes. So this is an evaluation that I want all of you to take a look at, right? Quant includes all of these features over here, a lot of questions, a lot of interactive material. The best thing is the division of questions. So as you can see over here, the 234 questions that you can see on your screen are just to test what is your starting point. The 462 questions are just to test if you know the concepts properly or not. The 431 questions over here are just to test whether you are able to apply the concepts, and these are the ones to test if you are ready for your GMAT or not, right? So a very wonderful experience. I'd all recommend all of you to go check that out. The link is over there in the poll over here, chat pod over here. Also, again, if you do these things in their correct order, this will definitely lead you to success, and that's what we have. We have the most number of Q49 plus scorers, and we have the most number of 700 plus reviews on GMAT Club. And our students are a perfect example, and they speak for us, not right? So we can check that out as well. In case you need to talk to one of our GMAT strategy experts regarding strategy, regarding how much time will you take, regarding the metrics that you need to track, you can also book a free call with one of our GMAT strategy experts. Please note that this is only free for a non-eGMAT student. If you are an eGMAT student, please attend the onboarding sessions. We have 2 onboarding sessions every week on Thursdays and on Fridays. So please make sure you attend that. You can chat with one of our strategy experts live in that session. Okay, so with that, let's now move on to sprint 2. In this sprint, we have 2 very interesting questions for all of you. The first question at your screen, Harsha would just give you the poll over here. All the best for this one. All right, last 10 seconds for this one, guys. Not at all that difficult question, right? I'll give you another 10 seconds. Please mark your answer over here. All right, let's get started with the solution for this question. And before that, let me very quickly give you the accuracy numbers over here. All right, the accuracy for this question, let me also put in my video. Okay, so the accuracy for this question is at a 35%. Now, is that difficult? Is this question that difficult? The interpretation of this question is difficult. Once you understand, it's not going to be any difficult for you. So I'm just help you out how through process skills of visualization and translation, you understand the question in and out, because after you understand the question in and out, it's not going to be any problem. Right. So let's get started with the first statement that we have over here. A quiz game presents quizzes in progressive difficulty level to its players, with D1 being the lowest difficulty level, D2 being the second lowest, and so on. So D1, D2, D3, these are the quizzes that I would get. Each quiz has 10 questions. Okay, very important piece of information. The game is designed such that if a player answers even one of the 10 questions wrong, he has to take another quiz of the same difficulty. So for example, let me say that I'm taking D1. I mark 9 of these correct, 1 incorrect, right? 1 of these incorrect. Now, if I mark this incorrect, I have to take D1 again, right? If in the second attempt I mark it incorrect, I have to take D1 again. So that goes on and on, right? Okay, so when a player answers all 10 questions of the quiz correctly, he progresses to the next quiz of higher difficulty level. Now, I have a player whose name is Tom. Tom starts playing this game. His probability of answering the question incorrectly is 0.2 for D1, and for D2 it's 0.3. Okay, incorrectly. I guess a few have missed out on this, so we'll check that out. Sashank has a question. Why have you assumed and? I will come to that, Sashank. Very good question. I'll definitely come to that. So incorrectly in D1 is 0.2 and incorrectly in D2 is 0.3. What is the probability that after taking 2 quizzes, he will not have progressed to D3? That is what I need to find out. He'll not progress to D3, right? So interpret the data. Tom answers all questions. The probability of Tom answering all questions correctly, each question correctly in D1 is 1 minus 0.2. Now here again, some of you might make a mistake. Some of you might take the probability of answering it correctly as 0.2, but you have to make sure you read the question properly. Same for D2, it's a 0.7. I hope no questions till this point. Now, we need to find out the probability for Tom not progressing, right? And so I'll just visualize this case. In which case would so the only case where he will be served D3. So the only case where he'll progress to D3 is in the first quiz he gets all questions correct. That's D1. In the second quiz he gets all questions correct. That's D2. Only then he'll get the third quiz in the third attempt. Our event is that he should not progress. So what should be our non-event? If our event is not progressing, our non-event is opposite of that. That is progressing, right? So the non-event probability would be, what's the probability of he progressing to D3? We know one very important piece of information that probability of non-event is probability of event is equal to 1 minus probability of non-event. We already know that. So let's first calculate the probability of non-event. What do I mean by non-event? I'll very quickly again run you through. Here, our event is he'll not progress. Keep that in mind. He'll not progress to D3 is our event. So the non-event would be opposite to that. That means he will progress, right? Okay. So with that, let's move ahead. What do we have over here? We'll have to first calculate the non-event. That is, he will progress. If he progresses to D3, he needs to get all questions in D1 correct, and he needs to get all questions in D2 correct. Sashank, here is your doubt. I have to make sure that he gets the first set of questions correct and the second set of questions correct, only then he will move into the third quiz. I hope that answers your question. And means the multiplication symbol over here. Okay, so with that, what's the probability of answering each question? 0.8. For answering 10 questions correctly, to the power 10. What's the probability of answering one question in D3? D2, 0.7. For answering 10 questions, to the power 10. So the probability of non-event is 0.8 times 0.6, which is 0.56 whole to the power 10. Right? Now, what's the probability of event then? We already know that. 1 minus the probability of non-event, which is 0.56 whole to the power 10. So the probability of event that he'll not progress to D3 is simply this, which makes choice E the correct answer choice for this question. Now, if you try to do it in the event manner that he'll not progress, you have to make cases. The first case is he'll not get D1 correct. The second case, he'll make 2-3 cases. There might be chances of errors. And that is the reason the non-event functionality in probability is a very crucial tool to get questions correct and to get questions correct in a shorter amount of time. And always notice that these questions that I'm giving you, and these questions are essentially questions in which the non-event, if you don't use that concept, the question difficulty increases substantially. So always make sure you understand this. Right? Okay, Maverick has a question. Can you use the event non-event process for majority of probability questions? Absolutely. And that's the beauty of it, Maverick. And that is the reason I'm giving you these questions, so that you become strong over these ones. Right? I hope it's clear to all of you. Thanks a lot, Tejas, to help out, and Mehul to help out Shashank on his query as well. Thank you, guys. Thank you, both of you. All right. So with the learning for this question, from this question, we'll now move on to the most challenging question for today's session. Question number 2 in Sprint 2. The answer poll would be in the comment section, as you can see. And yes, Tejas, the difficulty level for this question is definitely 700 plus, and that is the reason why only 40% of you got it correct, right? Okay, so this is the most challenging question in today's session. All the best for this one, guys. All right, last 5 seconds for this one, guys. Last 5 seconds. If you have not marked the answer, please do so. And very honestly, I'm very happy. The reason being that 63% of you got this question correct. And this definitely is one of the most challenging questions in this session. I would rather say the most challenging question in this session. So I'm very happy to see this accuracy. All right. So with that, let's first read the question and get to the solution part over there. Before that, if you love the session, if you love the questions and the solutions, I request you to please press the like button. It's a great motivation for us as well, and we know that you're loving what we are doing for you, right? So yeah, please press the like button if you are liking the session over here. Okay, so now let's move into the question. A box contains n shirts. That's what I have over here, of which 60% are white in color. 3 out of every 4 non-white shirts have a tailoring defect. What percentage of white shirts do not have a tailoring defect? So that's something that I have to figure out. So let's first understand what the question stem is giving me. Okay, one thing that we at eGMAT tell you is if you want to become strong in GMAT data sufficiency, always make sure that before moving into the statements, you do a proper operation of the question stem, right? Do cut it out and make sure that you understand the question stem in and out. So if you do that, your accuracy in DS questions obviously would improve a lot. So let's first do the same thing over here as well. What do we have? We have a box that contains n shirts, right? So let's visualize this scenario. I have a box. The total number of shirts that I have is equal to n. Now, 60% of these n shirts are white in color. So there can be two possibilities: shirts which are white, shirts which are not white. Now, 60% are white in color. 60% of what? 60% of total shirts, that is equal to n. That means 0.6 n are the total number of white shirts that I have. Now, if the total number of shirts is n, white shirts is 0.6 n, then the total number of non-white shirts would be equal to 0.4 n, the difference, right? Okay, now, the question also gives me this information that there can be defective shirts, there can be shirts without defects. So let's divide the shirts, both white and non-white, into these two types: defective, non-defective, defective, non-defective. Now, it's given that 3 out of every 4 non-white shirts have a tailoring defect. How many non-white shirts do I have? 0.4 n. 3 out of 4, that means 3/4 of this number is defective, right? Which is equal to 0.3 n. If I have a total of 0.4 n non-white shirts, out of which 0.3 n are defective, the remaining 0.1 n has to be non-defective shirts, right? Okay, so that's about the non-white shirts. Let's now come to white shirts. Do I have any information? Not much. So what we would do is we'll assume that the number of defective white shirts is equal to x. Now, if the total number of shirts is equal to 0.6 n, the defective shirts are x, the non-defective shirts would be 0.6 n minus x. This is an entire flowchart. Now, you might ask, Athreya, why do I need to do this, man? Why do I need to expend almost 30-40 seconds to do this? Because if you do this, trust me, accuracy would increase. I do understand that this process would take you 20 more seconds or 30 more seconds. You would either do it in normal notes as well. So you might do it in this manner. I'll just note it down. Total shirts, white shirt, this shirt, defective, non-defective, defective, non-defective. This might get a bit hodgepodge over here. I want you to keep things very in front of your eyes, which are very much visible, so that the accuracy increases, right? That's essentially one very key aspect over here. Now that we have this, let's move on to the statements. What's the first statement telling me? And even before that, what's the question asking me? The question asks me what percentage. So what do I need to find? What percentage of white shirts do not have a tailoring effect? So I have this figure over here. What are the total number of white shirts? The total number of white shirts is equal to 0.6 n. How many have tailoring effect? So how many do not have tailoring effect? 0.6n minus x, right? So the percentage of shirts, white shirts which do not have tailoring effect is the number of shirts that do not have the tailoring effect divided by total shirts times 100 percentage. So essentially I need to find out this value. And if you simplify this, 0.6n divided by 0.6n becomes 1. X divided by 0.6n is this expression that I have over here times 100. So I need to find out what is the value of x by n. Any statement that gives me the value of x by n is a sufficient statement for me to answer this question. So we need to find out x by n or simply x in terms of n. Any statement that gives out that data is a sufficient statement. With all of this analysis that almost took me a minute, if I'm solving it on paper, obviously not explaining, I'll now move into the first statement, statement 1. What is statement 1 telling me? If one shirt is selected at random from the box, the probability that it will have a tailoring defect is equal to 0.5. Now remember that figure that I have. One shirt is selected randomly from the box. So out of how many shirts am I selecting? I'm selecting out of n shirts. What kind of shirts am I selecting? I'm selecting shirts which have a tailoring defect. So it can be either a white shirt or a non-white shirt, but I have to make sure that they have a tailoring defect in them, right? So these two are the numbers that I'm looking for. So total defective shirts in that case would be what? Defective white shirts, which is equal to x, plus defective non-white shirts, which is equal to 0.3n. Out of what am I choosing? I'm choosing from the box. So I'm choosing out of all the shirts that I have. That is n shirts, right? So the probability of being defective would be equal to the total number of defective shirts by the total number of shirts I am choosing from, and according to the question, that's given as 0.5n. Okay, if I simplify this, what do I have? I have x by n, and then I have 0.3 by n, and in that case n and n cancels out. So I have x by n plus 0.3 on the right hand side. On the left hand side I have 0.5. Obviously I can see that the value of x by n is gettable through the statement. If I can do that, the first statement is a sufficient statement for me. I hope the solution is clear to this one. Let's now move on to the second statement. What's the second statement giving me? The second statement gives me the probability of a shirt with tailoring defect will be white. So, okay, the shirt has a tailoring defect and the probability of that being white is equal to 2 by 4. So let me again draw that. I'm looking for shirts which have a tailoring defect. I have to choose from them, right? So how many total defective shirts do I have? Again, x plus 0.3n. Okay, I have been given that the probability of the shirt that has a tailoring defect and that would be white is 2 by 5. So how many white defective shirts do I have? I have that to be equal to x over here. Now, according to the statement, 2 by 5 is the total number of shirts which are white and have tailoring defect divided by the total number of defective shirts. Okay, so I have this information. What I'll do is, now the denominator looks a bit complex. Let's do something. Let's inverse the equation, right? Inverse the expression over here. So 2 by 5 becomes 5 by 2. The numerator now becomes x by x plus 0.3 and denominator becomes n. Now, this is very similar to what we had in the last statements analysis as well, right? So I divide x by n, I divide 0.3 by n, I have the value of x by n. Now, if I have the value of x by n, again, it's a sufficient statement. So statement 1 is sufficient, statement 2 is sufficient. If both the statements are sufficient in a DS question, what's the answer? The answer is choice D, right? So a bit involving question, a bit complex question, but yes, if you can solve this question, if you can visualize all the cases that we discussed, I'm very, very sure that your ability in probability has to be top class. Again, if you have any questions, you can just go behind, rewind the video a bit and look at the solution once more. With that, I'll now move on to the process skills, because this is something that I used, right? I used how do you translate information that you have in questions? How do you consider all the cases? How do you visualize? Very, very important when it comes to probability questions, when it comes to word problems, algebra, geometry, PNC, all of this, how to infer information. To know more about these in detail, we have a free video series of this on YouTube. The link is in the comment section below. You can easily go there and check that out. Apart from that, we have two very interesting upcoming sessions. One on Saturday, Rajat will be taking that. It's on GMAT strategy. And the other is on number properties. That's on Sunday, same time, 7 a.m. PST, which is 7:30 p.m. IST. Both these sessions are really very engaging, and we'd love to see you over there as well. To register for these two sessions, use the link that you have in the chat bar. And I would love to see all of you experiencing the adaptive learning technology that we have built as a product in Quant 2.0 trial. So go and create your account, check that out. If you want to talk to one of our strategy experts, you can use this link to book a call for the same. With that, the concluding remarks, do make sure you have a study plan, attend the next set of sessions, solve the free trial questions, check your Scholvanium data and make improvement plans based on that data, and then track your improvement. If you love the session, I would love to have feedback from all of you. You can post your feedback either in the comment section over here or in the form that I've floated over here. Harsha would also share the session PDF with all of you so that you can refer to that whenever you want to, again, solve some questions on probability. With that, thank you for attending the session. It was very nice, interacting with all of you. I hope your time was fruitful as well, and you learned a lot of things. We'll again come with more number of sessions on GMAT, Quant, and Verbal, and Strategy. So stay tuned. Have a very good day or a good night ahead, and take care of yourself. Bye-bye.